The next speaker is actually Dr. Jason Jeffrey, who is the Director of Strategic Initiative for National Information Standards Organization, Baltimore, USA. And and recently I was also involved with him in one of the international conferences. I was lucky enough in that. And first of all, I would like to actually invite Dr. Jason. I would like to it's my privilege and an honor to introduce Dr. Jason Jeffrey. He is the Director of Strategic Initiative at National NISO, where he works to identify new areas of information ecosystem where the standards expertise is useful and needed. Prior to joining the NISO in 2019, Dr. Jason ran his own technology consultancy company for libraries, and he has been both in affiliate and Meta Lab and a fellow of affiliate at Berkman Klein Center for Internet and Society at Harvard University, and was an academic librarian in roles ranging from reference and instruction to head of the IT at the University of Tennessee at Chattanooga. Dr. Jason written extensively on technology and libraries, including multiple books and a series of full periodical issues on technology topics, most recently on AI and machine learning in libraries and library space and smart buildings technology, metrics, iterative design from 2018 onward. He has spoken internationally on topics such as artificial intelligence, machine learning, the future of technology and libraries, decentralization, the blockchain, privacy, copyright, and intellectual property right. He is one of the 8 winners of the Knight Foundation Youth Challenge for libraries for the measure of the future project, an open hardware project designed to provide actionable use metrics for library spaces. He is also the creator and director of the Library Box project, an open source portable digital file distribution system. Dr. Jason can be stalked obviously online and spend his free time with his daughter Eliza, reading, obsessing over gadgets, and preparing for the Invisible Zoomy uprising. So I would like to thank you, sir, for accepting our request and going to give an interesting talk to our student. Now, I request Dr. Jason to deliver his talk on artificial intelligence and the future of the research. Over to you, sir.
Thank you so much, Dr. Amaya. Thank you all for being here. Hopefully everyone can hear me fine. I am going to share my screen. Give me one moment here. Okay, so because Google does not like me, I have to quit and come right back. So in order to share my screen. So no apologies. This will take just 5 seconds. So I will be right back. Hello, can anyone confirm you can see the shared screen or no?
No, not yet.
You cannot see the screen. Okay. No. Let's try this again. Can you see the screen now?
No.
Okay.
Yeah, now coming up. Yes, coming up. Yes.
All right, there we go. It's trying.
Yes.
All right. So how about now? I hope we'll see a slide. Is that correct?
Yes.
Excellent. Okay, so if you see my slide, we're good to go. Apologies for that. This is very early in the morning here for me, so I'm still getting things set up. Thank you for being here, and thank you for joining me. I very much appreciate the ability to speak with you. It is about 8 o'clock in the morning here for me. I know it is in the evening for you. I wish the world were different and I could be there to be in person with you, but we will do our best to get the presentation across this way. First off, I would like to introduce myself very briefly. That was a wonderful introduction by Dr. Ramaya. Thank you so much. I am Jason Griffey, My background is as a librarian. I have a degree in library and information science. I have worked as a librarian for more than a decade. I am currently not in a library. I am working for the National Information Standards Organization here in the US. And I am joining you because a few years back, I wrote, along with a few of my library friends, a small book entitled Artificial Intelligence and Machine Learning in Libraries, where we examined the potential for machine learning inside libraries. This is actually available for you for free if you would like to download it. That URL will provide you with a PDF copy of this document, and then the QR code, if you scan it, will also do the same thing. So I'm able to share this with you here today. Give you just a second to note that, and then I'm going to spend the next roughly hour talking to you about a number of things in the world that have to do with artificial intelligence and machine learning. We're going to talk a little bit about the state of AI right now. What do I mean when I say artificial intelligence? When we talk about artificial intelligence, what are we talking about? I'm going to talk a little bit about what it is, how does it work, actually go into a little bit of the explanation of how it does what it does. We're going to look at some examples, both in media and what artificial intelligence and machine learning can do in the world of sort of images and video and audio. What sort of world are we living in, and what sort of changes can be made by AI in those spaces. We're going to talk about library examples of AI and machine learning, and what libraries should be looking at there. And then I want to take a few moments and talk about the sort of future of what AI and machine learning might do in the library and higher education space, and what we may see over the next several years. And then I'll have some concerns and conclusions at the very end. So what do I mean when I say artificial intelligence, right? Like it is a word, a phrase that has a lot of different meanings to a lot of different people. We have sort of two kinds, very roughly, of artificial intelligence that tend to be talked about in the world: weak and strong. Sometimes this is called general or applied. I like the term weak AI and strong AI. Strong AI is the sort of science fiction movie artificial intelligence, right? It's a machine that can think like a human. And there's plenty of examples of that in media and movies, right? Think of any number of different science fiction novels and or films that feature a strong AI, a machine that just acts as if it is a human being. We don't have this in the world, and there are good reasons to suspect that we will never have this in the world. That this having an artificial intelligence that is capable of sort of the full range of human-like behavior and understanding, it may actually be an impossibility. But what we do have is weak AI. And weak AI is usually, again, this is sort of applied AI. This is where you have a machine system that you teach to do a particular task, and then the machine can do that task by itself without any sort of further human interaction, right? There are a lot of varieties of this. We're going to talk about a number of them, but the key and the difference to remember is that weak AI, which is the AI that we have in the world right now, all around us, is AI that does one thing, sometimes very, very, very narrow, mostly very, very narrow things. So as an example, right, so this is a result from my phone. This is from my iPhone. I searched in my photos for the word ocean. And when I searched for the word ocean, this was the result. This was the pictures that it gave me back, right? So how did it know that those are pictures of oceans? Well, because there's a small machine learning tool inside my phone that has been trained to recognize what an ocean looks like, and then it compares that training to the photos I take and classifies them, right? But that's all it does. It classifies images. It can't play a game. That AI doesn't know how to play chess. There are AIs that know how to play chess, and there are artificial intelligences, machine learning systems that play chess better than a human, but this AI can't do that, right? It is only capable of classifying pictures, classifying photographs. If we asked it to analyze text, it wouldn't be able to do that either, right? So that's what we mean when we say, when I say sort of strong AI or weak AI, is that the AI systems do a very narrow thing, but they do it very well, and they do it automatically without human interaction. These, from a library science, information science point of view, none of these photographs were had carefully curated metadata added to them by a human cataloger. These were classified by a machine, not by a human. And so this is an example of the sort of AI that's all around us, right? Every cell phone these days, every popular phone has, at the very least, a machine learning system that's classifying photographs in the background. And probably several other machine learning systems doing several other tasks for you without your knowledge. So there's an example of a weak AI that is sort of all around us. So AI is only as good as the data that goes into it, right? So the fact that my phone can tell me which pictures I take are pictures of oceans depends entirely on the training that the machine learning system received when it was being developed, right? So it's all about the data that goes in to the training set of the machine learning system in order to determine whether or not that machine learning system is doing a good work and actually classifying things appropriately. So let's look at how a machine learning system, at least one kind of machine learning system, does this with data and classification and things. So there's a number of different kinds of machine learning systems at this point, a number of different models. All of them, however, depend on a couple of functions in order to sort of get them moving, in order to get them doing what we want them to do. Those two things are data and training. The machine learning system has to have a large amount of data that has to do with the sort of thing you're teaching it, right? If I want to teach a machine learning system to identify different kinds of fruit, then I need photographs of lots of fruit in order to show it, right, to teach it what the different kinds of fruit are. If I was training it to determine what kinds of animals it saw, I would need photographs of animals. If I'm training it to recognize faces, then I need photographs of lots of faces in order to teach it, right? So we have to have a data set that is related to the skill you're trying to teach the machine learning system. And then you have to take that data and train the system. Tell it which ones are good, right? Which fit your desired outcome, and which one doesn't fit your desired outcome. So in the example here of training it to identify fruit, right? We give it a lot of photographs, and then we tell it, okay, that is an apple, this is a banana, that is a pineapple, this is a peach, that is a coconut, etc. So we tell it, right, which kinds of fruit each photograph is, And then over time, it learns to identify what those different fruits are, and you can then give it raw input and ask it what kind of fruit is this. So you have to have data, a lot of different examples of the thing in question that you're training it to do, and you have to have training. You have to have a human somewhere in the process to say, okay, yes, that's a positive example, or no, that's a negative example of the thing you're trying to do. You can also take machine learning systems and put them together in various ways in order to have them work together to generate an end. And this is my favorite example. There's lots of examples. This is just one way of understanding how machine learning systems might work together in order to do something for us. So this is a quick example of what's called a GAN, a G-A-N, a generative adversarial network. Excuse me. So this is an example of a machine learning system where we want it to create something for us. And we have two different machine learning systems that are going to work together in order to do this. We have one is called a generator. It creates new things. And the other is called the discriminator, which is the piece of the machine learning system that decides whether or not the thing that was created fits our model, right? So you have something that creates and something that decides, so that you have effectively sort of data and training going on in this system. So the way this works is you have a lot of data. Let's say this particular system, we are trying to train it to create pictures of cats. We really like cats, and what we want is an artificial intelligence. We want a machine learning system that does nothing but make us pictures of cats. All right. So how do we do that? Well, we start by giving it lots of pictures of cats. We download hundreds of thousands of pictures of cats from the internet, and we give it to the discriminator and say, this is what a cat looks like, right? Here are all of our examples of cats. Here are all of our cats. And then we go to the generator and we say, okay, make us a picture, right? Well, the first picture that it makes is going to be garbage. It's going to be just nothing, because it doesn't know what it's doing. You've asked it to do something where the generator, right? These are not connected in any way yet. So the generator just says, well, I don't know what you want. Here's a picture of static. I don't know what I'm supposed to be doing. Well, the key then is that you give the generated data to the discriminator. So you're taking the output of one machine learning system and using it as input in the second, right? And you say, does this look like a cat? You ask the machine learning system, and the machine learning system, the discriminator, says, no, that does not look anything like a cat. This is what a cat looks like. And the generator is then asked, well, okay, we'll do that again, right? Make another picture. And then it creates a second picture, and that second picture is probably a little closer to what a cat looks like because it's learned a little bit, but it's still not really a cat, right? But this is a computer system, and it can do this hundreds of thousands of times a second, right? It can take this data, ask the question, generate something new, determine whether it's correct, ask the question, generate something new, determine if it's correct. It can do this cycle thousands and thousands and thousands of times every second. And so in a very short amount of time, this system is going to be generating pictures of cats. It's going to be creating entirely new pictures of cats based on the model data and the training that we fed it, right? So this is a generative, generative system using machine learning. So this is just one example of the sort of system that you could have in a machine learning example. So let's look at the sort of examples that you can, the sort of things that you can do with systems like this. Right? What do you do with these sorts of machine learning systems? Well, so here's a great example, right? The example I used was, let's make pictures of cats, but obviously you don't have to make pictures of cats. You can make pictures of anything, including people. So here is a test for you. One of these photographs is of an entirely fake person that was generated by an AI system, right? So one of these is real, and one of these is not a real person at all. They are entirely a fake person, okay? So take just a second, look at the pictures, and just, I want you to think, in your head, which one do you think is real? Do you think the one on the left or the one on the right is real? All right. So everyone is wrong. I lied to you. They are both fake. These are not, neither of these are real people. These are both entirely fake people generated by a machine learning system. When I started doing this sort of presentation and talking about the things that machine learning can do for us, it took really high-end computer systems to do this sort of work. You had to have a very expensive computer to do sort of the creation of these sorts of images. And now it's a website. If you visit the website thispersondoesnotexist.com, it will create new people for you at the click of a button. It's just a website that does nothing but generate fake people for you. So it's gone in just a few years, just a couple of years. It's gone from the sort of thing that's a very expensive computing exercise to the sort of thing that is a service on the web, just a website. So other examples of the sorts of things that machine learning systems can do with media, right? And this is just, I want to show you some of the things we can do with pictures and with video before we get to sort of books and text. So this is actually a photograph of my grandmother. This is my maternal grandmother, and there's several AI systems, machine learning systems, that have been trained to take old black and white photographs, right, old photographs, and to colorize them, to make them in color, right? So it's been trained on old photographs and new photographs, and understanding what, likely colors of lips and eyes and hair are, and it will automatically sort of colorize photographs for you. The example here of my grandmother is good. This is an interesting example, but it can be very, very good with enough training data. So this is an example of a photograph here from the Depression era U.S., from the sort of the 1920s here in the U.S., being colorized by a machine learning system called De-Oldify, which I'll have the URL for here in just one second. This is the sort of thing that can be done just automatically with an AI system. And it doesn't have to just be still photographs, right? It can be moving pictures as well, because video is just a series of still photographs. It's the same thing. So you can do, this is a clip from the film Metropolis by Fritz Lang. And you can take old movies and do a similar sort of thing, where you basically give them to a machine learning system and have them turned from black and white into color. This one is even, I think, more remarkable in a lot of ways. So this is an example of a machine learning system being trained to understand what human faces look like and to understand what video of human faces look like. So this is, again, the same picture of my grandmother, right? This is the same picture I showed you a moment ago. This is using a system called Deep Nostalgia. The system takes still photographs and then makes them into video of the person in question, right? Now, it's not perfect. It's a little, you can, if you watch it carefully, especially if you watch it several times, you can tell that it's not sort of real video of my grandmother, but it's pretty good. And this is as bad as it will ever be. It will never be any worse than this, right? Computing and systems will only get better over time. And so over time, this sort of thing will look more natural. It will be more real, if you want to understand it that way. So this is another example of the sort of things that machine learning systems can be trained to do these days. I concentrated a lot on video and on visual because it's very easy to see, but you can do this sort of work with other types of media and with other types of creativity, sort of. This is an example of an AI that's trained on music, and it takes a song and separates the instruments from the voice and gives you two different tracks, right? So you can take any song and drop it into this AI, and it will analyze it and pull apart the voice and the music, which is kind of magic if you know anything at all about audio. It really is sort of magical to see this do what it does. Again, it's not perfect. It's a little messy, but it is very, very good for what it does. So it's not just video and photographs and things. It's also audio that you can manipulate in a variety of ways and other things, right? So this is another example of the sort of machine learning systems that are out there these days. For those of you who may be developers or coders or programmers, GitHub, which is a very popular tool for programmers, has a system called Copilot, which will watch what you are writing and suggest what you may need as the next part of your program. So it will understand the sort of coding you're doing and then give you suggestions for the next part of the program that you may be writing through AI. So it's kind of like having an invisible friend helping you program as you go. So again, sort of thing that an AI can be trained to do. So let's look at a few library examples. Let's see, what sort of work can be done by machine learning systems in libraries with information rather than with photographs and things. Certainly lots can be done already. You're probably having ideas and thinking through the sorts of things that might be done with media inside a library using some of these tools. But let's talk specifically about sort of library tools. There are a number of library tools sort of in the world, or tools that are library adjacent. A couple of them that I'll just point out right now. One of them is called ANIF, ANNIF.org. ANIF is a system that is trained to take text and apply subjects to it. So you have in a very classic sort of cataloging way, it will take a text and then generate the subject vocabulary for that text. So you can, classify things much more quickly. It is trained in several languages. It isn't every language in the world, although they're adding things all the time. This was originally developed in Sweden, I believe, and so it has Finnish and Swedish as well as English. You give it text, and it will say, this is, insert controlled vocabulary. This is about the United States. This is about the University of Oxford. This is about. It will give you sort of subject headings for the text in question. So super useful for cataloging and for sort of doing first passes at large cataloging jobs. One of my favorite examples of the sort of thing that you can do when you put a number of machine learning systems together. This is not directly a library tool, but it's so obviously the sort of thing a library should be doing that I always like including it. This is a search engine called Flim, F-L-I-M, flim.ai. And this is a search engine that has indexed films, mostly U.S. films, although some non-U.S. films, but mostly U.S. films. It has indexed the frames of those films. So all of the individual pictures that make up a film, it has indexed all of those. And then it has applied a machine learning system in order to determine what's in those frames. So as an example, this search result you see here is me searching for a red car. I said, show me films that have red cars in them, right? And it isn't always correct, right? There are a number of images there that are red with a car, but the car is not red, or red but not a car at all, right? There are a number of incorrect search results, but in general, right, being able to search for a film that has a green jacket in it, or a films that only have beaches in them, or for someone who's doing media research, or for someone who's doing a variety of scholarly sort of endeavors on media. This is an amazing tool. It's the sort of tool that years ago you couldn't have even imagined having, right? It's just too much data, no way to index it, no way to do the retrieval and make it work. No, it's a search engine that even 10 years ago probably couldn't have existed. But now, here it is. And it's, again, only sort of the first of these complicated, fully featured search tools. One can imagine applying this sort of idea to a number of things, right? Including library catalogs, where if we had access to things like the electronic text of the works in question, we could surface ideas and not just titles and authors. We could say, show me books that have horses in them, in a way that is far more robust than just subject cataloging is. We could actually understand what's inside the books in the way that this search engine understands what's inside the movies. And this is really only works with machine learning and AI. There's no way to do this without those tools. And then finally, my favorite example of a library tool that's built with machine learning. And this is a tool that was actually built by a librarian. This was a tool that was built by a librarian named Andromeda Yelton. She had access to the electronic theses and dissertations at MIT. And so she built a tool called Hamlet, How About Machine Learning Enhanced Theses. And this indexes all of the electronic master's and PhD papers at MIT, at the Massachusetts Institute of Technology. What's different is that it's a search engine and it indexes them, but it doesn't do it with any humans. It's only using a machine learning system to do the indexing and understanding of what these papers are about. And so if you search for oxygen, right, you might get papers from biology, where oxygen is obviously important, or you may get papers from rocketry and outer space exploration, because oxygen is a fuel system in those ways, right? With a tool like Hamlet, you could actually say oxygen rocket and only get those theses and dissertations that have to do with oxygen as a fuel and not oxygen in living things, because the machine learning is smart enough to identify and know that those are different clusters of ideas. So that's one example. My other favorite example is you can actually give Hamlet an existing text. So let's say you have a paper, you find a paper, right, that is important to your research, and you want to find other things like that paper. Well, you can actually give Hamlet that entire paper. You can just upload the paper to Hamlet. Hamlet will analyze that paper and then give you other papers that are like that paper, right? So if you give it a paper about chemistry, or so let's say, nitrogen-based chemistry, to stay with rocketry, if you give it a paper about nitrogen-based chemistry, it will return to you papers about nitrogen-based chemistry and not papers about nitrogen as a fertilizer in biology, right? It's an amazing tool. My favorite example is that when the first time I saw this tool, I was interested in trying to figure out where its limits were. And so I gave it the text of Peter Pan, the J.M. Barrie novel, the English fantasy novel about the boy who will never grow up. So just Peter Pan. I gave it that, and I asked it to give me PhD theses that were like Peter Pan. I expected it to fail. I expected it to fall apart and to not, either to give me nonsense or to give me maybe papers about flying or something. Like, I expected it to be wrong, but I wasn't sure how it would be wrong. And that's the interesting part, right, in testing it. Instead, what it gave me was all of the creative writing theses from MIT. I didn't even know MIT had a creative writing program, but the system was smart enough to look at Peter Pan and say, well, this isn't research, this is creative, this is a piece of fiction, and then to then show me papers that were about fiction rather than about, again, flying or aviation. So anyway, fantastic tool, amazing resource. This is the sort of thing that I think we should see in libraries much, much more often. This was built several years ago, and I'm always surprised that other places haven't picked it up. So, all right. So we've given a bunch of examples of the sort of things that machine learning can do now. What do we think this looks like? What do I think this looks like moving forward into the future? Where are we going with machine learning, and what do I think we're likely to see? Well, I think there's a lot of things that we may see, but this is the one that's the most interesting to me, and that is that right now in libraries, a large part of our work, a large part of the work of a library, especially an academic library, right, is tied up in this, excuse me, in the research process. What is it that that people do to create new knowledge, right? And undergrads and early graduate students sort of learn this process. There's a you find a topic and you search for information and you gather your materials and you evaluate those materials and you take notes from those materials. Excuse me, sorry. You write a paper based on those materials, you cite your sources, you proofread it, and then eventually you publish it, right? This is the normal sort of research process that happens every day in libraries and universities all around the world. Every single one of these processes can now be assisted with AI or machine learning. And there are tools that will help automate each one of these processes. So I'm going to go through several of these. Don't worry, we're going to move very quickly because I don't have a lot to say about each of the tools, but what's important is the sort of arc of the work that's possible here. And I'll provide my slides, so don't worry about having to write everything down too quickly. But so doing your research, right? This is usually the purview of humans. You decide on a topic and then you go out and you find topics on that research. There are AIs that are beginning to do this for people. Right now, these are mostly in very narrow fields like law or medicine, sort of much more controlled, understandable fields than the entire world of research. Kara AI runs a system called Case Text, which will do automatic case research for you if you're a lawyer. If you're trying to find cases that are related to the case you're working on, you can feed it a case and it will find case law that is in your in your area. Wisdom.ai, your personal research assistant. It will help researchers and institutions find research based on grants and trends. You can give it your publications and it will find other things that are similar to your publications, right? This is sort of an automated, like a personal research assistant that's run by artificial intelligence in the background. Diffio, again, a very, very similar sort of thing. This is mostly based around sort of business intelligence and looking for research on businesses and corporations, but it's obvious that it could be applied to a number of other things. And then something like Iris AI, research discovery with artificial intelligence, use natural language processing to review collections of research papers or patents and find other documents, right? So these tools take the research process and automate it through AI and machine learning. So it lessens the need for a human to be doing some of that work. Well, surely, the human has to come back in and actually like read the things and take the notes and write the paper. Well, not entirely. There are tools like Resumer, which summarizes text for you. So if you give it a paper, it will summarize and take basically the highlights of the paper and give them to you. Scholarcy, which does a very similar thing, summary flashcards for any document that you feed it. So it will look at a paper and determine what the important pieces are and then give you summaries of that. EssayBot, which is my favorite because it says, EssayBot suggests best contents and helps you write. No plagiarism. It's a personal AI writing tool. You give it a title and some research, and it will work to try and write part of a paper for you, including checking your grammar and things like that. And then, of course, once you have something written, you can you can use AI proofreading tools and editing tools in order to make it sound better. You have systems like Grammarly, where it will analyze your writing and make sure that you're not making grammatical mistakes, or Writing Assistant, which will do a very similar sort of thing, right? Now, these are not available, these sort of systems are not available in every language, for every topic, in every, sort of research area. These are not universal, but they are there, and it's a very easy process to see how they sort of get better over time, right? They become less limited in their scope or scale, less limited in the particular language requirements or language limitations they may have. All of those systems will again sort of get better and bigger with more things they can do, etc. And while very early in this talk we talked about weak AI and strong AI, right? Where weak AI does very small things very well. You might say, well, yeah, okay, well, there's a system for this and a system for that, but you can't just sort of automate the entire information creation workflow. You can't, there's no system where you can just sort of give it a topic and it will do the research, summarize them, write the paper, do your citations. Like, there's nothing that's like a magic paper machine. And that's true, there's no magic research machine. But in the same way that when we looked at the machine learning systems that tied together, the generative adversarial network, where you had two of them working together in order to create something, it's very easy, I think, to sort of understand how the pieces may be done by separate machines, but then fed from one to the other. And you might have a chain of machine learning systems, all of which work with you to do a lot of the research process without a lot of human interaction. I'm not saying this is either good or bad. I am simply saying I think it's coming. I think this is a thing that we will likely have to deal with as information professionals and as part of the research and scholarly information world. We're going to have to sort of figure out how to deal with systems that do this sort of work. And again, we haven't seen this yet, but I think we will start seeing it fairly soon. So let's talk through a few conclusions. Let's talk through some sort of concerns and conclusions. What role do librarians have and libraries have in this new world where machine learning systems can do a lot of these things? There's actually huge roles for libraries, for librarians, and for information professionals in these spaces. As we said early on, data is a big part of the world of machine learning. You have to have data, and not only data, you have to have good data, reliable data, data that is not misleading or data that is not biased in some way, because if you have data that has a bias, then the system you're training will reflect that bias, right? An example, here in the United States, there are machine learning systems that are used in the US judicial system, in our court system here, in order to determine sort of fair sentencing for criminal cases. So if someone is found guilty of a crime in some jurisdictions, in some places in the US, there's a machine learning system that will take a look at the details of the crime and compare them to historical data about similar crimes and make recommendations for sentencing of the criminal. So that sounds I mean, it sounds scary to me, but to some people it sounds reassuring that there's a sort of process by which this sort of thing gets done. The problem is that the data that the tool is based on is just historical sentencing data. It's data about what has happened in the past with criminal sentencing. And we know here in the US that criminal sentencing has a huge racial bias, that people of color, specifically in the US, Black people, have a much worse sentencing rate. They have longer sentences for the same crime than do other races, specifically white people. And so the bias that's in that data is then being reflected in the future use of the machine learning system. Libraries and librarians and information professionals know about this, and they know how to help fix data. So data normalization and data, sort of ethical data use, is something that will be a huge opportunity for libraries and librarians moving forward into this sort of machine learning future. The second is training, right? Again, I've said this several times. We have data, and then we have training, and determining whether the data and the machine learning system is doing what we expect it to do is part of that training process for any machine learning system. And again, libraries, librarians, information professionals can be can understand, can help computer scientists understand that sort of the needs of the training, what it is that may be going wrong in the data that lead to sort of questionable outcomes, and then how to improve the training system based on that data. And so this is something that I think will be a bigger and bigger role over time for librarians and for information professionals. And then the last is sort of the evaluation of the output of a machine learning system. Even if you don't know the data and you don't know the training that went into a system, it is still possible to watch a machine learning system operate and just look at the outcomes, just look at the outputs, and evaluate those outputs to know whether or not the system is being fair or just. That it is a possibility to just look at sort of outcomes of a black box operation and determine, are these, is this tool fair in some way? And doing that evaluation is a really important part of determining whether or not a machine learning system should be used in a particular context. And so this is also something that libraries, librarians, and information professionals are pretty good at and should have the tools and skills necessary for. And so being evaluators of the output in order to determine whether or not a system has bias, has problems, has issues, is something that that libraries could easily do. So what are my concerns about this sort of new future with machine learning systems everywhere and working, in the background for people and things? What are the concerns I have? I have a couple of worries. One is that because of the sort of situation I just described, we only have data about the past. We sadly can't have data about the future. We can only have data about the past. And our past is full of mistakes. And so if we build systems that rely on data that we expect to make decisions in the future without determining whether the data and the decisions are good ones, whether they're just and equitable, then all we're doing is sort of codifying the old mistakes we made and continuing to make them in the future, right? That it's possible for us to believe that a machine learning system is some objective actor, when in reality, what it's doing is just taking the past and making it again. And that that is a concern I have, that we may just continue to repeat the mistakes that we have made in the past. And then the second concern, the second big concern I have, is that by outsourcing a lot of decisions to machine learning systems, what in the case of research, the kinds of papers that it brings me back, the kinds of resources that it searches, I may not have a full understanding of the limits of these systems. And if the machine learning system is built in such a way that it only ever gives me things that reinforce my question, then I will never see things that refute my question. I will never see things that disagree with me. I will only ever see things that agree with me. And so there is a potential for these tools to just create filters and bubbles of information that are internally coherent but wrong, because they aren't taking into account dissenting views. If our tool only shows us the things that we want to see, then we are never presented with things that that show us that we're wrong. And that is a big concern of mine for these sort of machine learning systems that help in research processes, because by their very nature, they're trained to find things that we ask them to find, and not things that that disagree with us. And so I'm really worried about that. That is a thing that does concern me a great deal. And then finally, just one last thought before we get to questions and such. Roy Amara was a American researcher and a scientist and a futurist here in the U.S. Roy said, "We tend to overestimate the effect of a technology in the short run and underestimate the effect in the long run." So all of the sort of talk about machine learning and what it might do over the next couple of years, we may be overestimating what it will do, but long term, I think it will have an extraordinary effect on the work we do as information professionals, the work that we assist with in the research and scholarly processes, and in general with the sort of information we collect, with the media that we collect, with the processes by which we sort of understand the works that we're putting into our libraries. All of these things are going to be affected by machine learning, and I think in the long term, it may be much weirder and much stranger than we can sort of understand. And that is the end of my prepared comments. This is me. This is my title, my email address. I am on Twitter at Griffey, if you'd like to follow me there, and then my website as well. Feel free to be in contact with me. Feel free to follow me on Twitter if you're interested in the sort of work I do. I'm always happy to talk and to help where I can. So this is me. I will stop screen sharing here in just one moment and be available for questions if people have questions.
I've turned on the microphone.
All right.
Yeah.
Dr. Ramaya, thank you so much, yeah. And I'm happy to take questions if anyone has any.
Yeah, dear students, if you have any questions, you can one by one. It was really interesting, and definitely students will have a lot of questions. Hello.
Good evening, sir.
Yeah, please go on.
So thank you, sir, for the wonderful session. So you had talked about the effects of AI also, and also the effect on the technology also. So the artificial intelligence, like you had mentioned, is having a positive impact on the STEM fields, science, technology, engineering, management fields. And so you had also mentioned about the effect of it, AI on the law, on the in the field of law also. So
Mhm.
how far it can be, how effective will be the artificial intelligence when it comes to the humanities field, and especially the law also, because the STEM field can be scalable, or this it can be on a monetary basis also. The more research is being done
Mhm.
on that field also. So
Yep.
what about the humanities field? How effective it can be, because there we are thinking with the other part of the brain. That many people are saying like that. So in the
Yep.
humanities, so how effective the AI will be in those fields?
That's a great question. You are completely correct that it's STEM fields where the money is, right, where it will sort of happen first, because they just have more funding than humanities fields in general do. They have a lot of a lot of opportunities for grants and things where humanities systems may or may not have those. I do think that in the humanities, what we are likely to see is a lot of the work that's done in under what's called digital humanities, right? Sort of using technology to analyze texts and to do a variety of different sort of analyses on texts. We're going to see that start happening in machine learning systems much more frequently. So I think we're going to see interesting scholarship from sort of the analysis of of humanities works in machine learning systems. It will be interesting to see how that funding and how that sort of works from a financial standpoint, because yeah, there's not nearly as much money. Law, I think it, law will have an easy time of it, because there is plenty of financial incentive to insert tools that make sort of legal processes more efficient and effective. So I don't think that I think law will be sort of along with engineering and STEM and medicine, as far as sort of being able to move very quickly into machine learning systems of varying kinds. Humanities will be a trailing effect, I think. And some of the interesting things that are going to be happening in humanities, I think, are going to be philosophical questions. We're going to have lots of arguments over the next several years as to whether or not a machine can be an author of things, or whether a machine can be a composer of music. Here in the US, there's been court cases about copyright and about intellectual property law relating to the outputs of machine learning systems. But I think from a scholarly point of view in the humanities, there's going to be a lot of scholarship done on how machine learning outputs should be treated as art, as creative outputs, as fiction. As we're gonna have a lot of arguments, I think, going on in that space. So it'll be interesting to watch, I think.
Students, any more questions, please?
Yeah. Sir, what do you think about analog computing in terms of AI?
Yeah, so I saw that question there. When you say analog computing, can you give me an example of the sort of thing you're thinking about?
Like adding analog elements to like store data and organize it.
Okay. Yeah, I am not as familiar with what that might look like, honestly. I mean, analog analog inputs for sort of creative works, I'm familiar with, but as far as actual computing, I'm not as familiar with what an analog storage system or an analog computing system might look like. Quantum, I've talked a bit about sort of what might happen once we get past binary, right? What a digital system, but not a binary system, where we can have computing that relies on more than just 2 bits. That is a weird and unusual place to be in computing, but I actually don't know much about the area that you're talking about as far as analog use in that space.
Any more questions, please? Because the analog, anyway, it is outdated. Nobody is using analog. Now we are all in the digital world.
Yeah.
Sir, I have a question.
Yes, please.
Yeah. While you are discussing about the concern, okay, the second concern is about the filters and bubbles. Can you please say what are the concerns you are facing in the area of filters and bubbles?
I'm sorry, could you say it one more time?
Yeah, while you are discussing about the concerns
Mm-hmm.
in AI, and you will be discussing about the filters and bubbles.
Mm-hmm.
May I know what are the concerns you are facing in the filters and bubbles, so that it will be useful for our research?
Yeah. My concerns there all have to do with the fact that AI, the machine learning systems and their data that they're trained with tend to, when you ask them to generate new data, they tend to collect things that are similar, right? That's, I mean, sort of the job of a machine learning system is to group similar things when you're asking one to do analysis of a data set. You know, if I ask a AI system, I train an AI system to show me, let's see, what would be a good example? If I tell an AI system that I'm looking for, let's go back to crime and the U.S. I want an AI system to identify areas where I shouldn't move because crime will likely be higher, right? The effect of asking that question, given the data that we already have, is going to be sort of biased because the outcomes are based on data that actually was collected in such a way that has racial bias built into it. And so when I get the results from that query, from that system, it's filtered in such a way that I don't see the entire data set. I only see the data that is sort of already tainted or biased. That's a problem in sort of machine learning systems in general. Another good example is the problems that we've seen over the last couple of years with social media, right? Social media, Facebook, Twitter, etc., use machine learning systems to determine what to show you, right, in your timeline. They usually call it an algorithm. They have an algorithm that, you know, analyzes whether or not it should show you a particular story. That it really underneath there's a machine learning system doing this, and in general, it only shows you things that you agree with. And so if you have a perspective on the world that is objectively wrong, factually wrong, but it is the perspective you want to see, social media will just continue to show you those things. It will continue to show you factually incorrect, but pleasing to you information. And so that sort of bubble, that sort of filter is terrible for society. That's really bad, because in an ideal world, you would be receiving information that would disagree with you and make you reconsider your own perspectives. And so that is the sort of piece of machine learning that I really worry about probably the most, is that from an information standpoint, if we only ever see things that agree with us, it isn't actually good for scholarship or good for understanding the world or good for society as a whole. We need, as humans, to see people and to see stories and to see perspectives that disagree with our own, so that we understand there are other types of people in the world, that there are other types of perspectives in the world, that our perspective might be wrong, and that we have to sort of think about that, right? That's scholarship does that all the time. Scholars do that all the time. But machine learning is really good at preventing that from happening. And so I worry that if we lean on these tools too much, that we will be in a situation where that is a problem.
Thank you, sir.
Any more questions, participants? Now, before that, I have a small question. Recently, yeah, please go on.
Good evening, sir.
Yep.
Sir, I have a doubt. As we are discussing about AI, so can you please explain me what is the difference of strong AI and weak AI?
Yeah, sure. So I talked about it very briefly, but the difference is that strong AI is sort of the fictional science fiction, what we see in movies, where there is a machine that is just like a human. They can interact with the world like a human. They can do. You could have an AI system. Excuse me. You could have an AI system that talks to you and plays chess and looks at pictures and does all sorts of things. It's sort of a general AI. It understands the world in a lot of different ways. Those don't exist. A lot of people would like them to, and there are places that are working on sort of trying to create that kind of AI. But the strong AI is just not something that we have in the world. And personally, my research and sort of my perspective, I actually don't think it's a thing that probably will exist. I don't believe that we have the capacity to create that sort of thing. Weak AI is an AI that's trained to do a specific thing, just to look at pictures and determine what's in them, just to play chess, right? We have AIs that can play chess, but if I ask that AI to play a different game, it couldn't, because it's trained on just that game, right? And that's an example of weak AI. So we have, and that's what we have in the world. That's the sort of AI tools that we have right now, are those that are very focused on a particular problem and doing one thing.
Thank you, sir.
Any more questions, please?
So, do you consider hybrid intelligence as a solution to the problems that you had raised regarding the concerns regarding AI? Do you consider hybrid?
Yeah, when you say hybrid, do you mean AI and humans working together? Is that what you're
Yes,
sort of? Yeah. Just to make sure. Yeah, yes, I actually think that sort of system is one that could be extremely powerful. That we have humans working with an AI system where the AI is doing a large amount of work, but a human is there to sort of guide, correct, understand, train, right? We have a human sort of in the loop of the processes in order to limit those sorts of problems that I laid out. So yes, and that's, I think, where librarians, information professionals, I think there's going to be a lot of opportunity over the next 10 years for people in this space to be that part of that hybrid sort of tool chain. So yeah, I think that's a big part of our future. I think you're muted, Dr. Ramaya.
I muted it. Sorry.
Yeah.
Yeah. Now, I have a small question. Now,
Sure.
where actually voluminous data is there, for example, like the meteorology, weather related, for example, like the genome research, Manually, when you do actually, it takes a long time. So these areas, if you apply the AI, we think it will be able to help us in doing the speed of the research, and we'll be able to do the better results.
Give me, I'm sorry, one more time. I wanted to make sure I understand the question.
Some areas we produce actually high volume of data. When we want to deal the data, for human it takes long time. For example,
Yes.
one is meteorology, weather related. Daily it will become. Another one is genome research. Huge amount will be there. So when we want to do research, of course, if we use these machine tools, and it will help us actually doing better. Actually, is that kind of research is going on? What is scenario of that?
Yes, that's a fantastic example of where machine learning becomes extremely powerful, right? We have, as you say, right, genomic, weather, there's a number of fields, astronomy, right, astronomic data. There's a number of fields where the data, it just vastly larger than any human could ever deal with. There's no way to get enough humans to deal with the data that is in question in some of these fields. And it's the perfect opportunity for a machine learning system to help filter that data and look for patterns and see the pieces that are that then humans should look at, right? To look at anomalies, to find patterns that are interesting in some way. And the keys there are for the training of those machine learning systems to be such that it's flexible enough to identify things, but and not rigid enough to ignore what might be interesting. It's a really tricky thing to teach a system to be flexible enough to identify things that might be interesting to humans, rather than ignoring some pattern or something that might be that it might miss. And so that's absolutely something that's happening. There are lots of places working on in that sort of space. It is a really hard problem in machine learning to do the training and to build the algorithms to make those systems do what we need them to do. But it is, and as you say, there's a lot of places where that's going to be more and more. I mean, oceanic data. There's like climate. There's a huge number of places where that's going to be extremely important over the next decade or two. So that's a great example of where machine learning is going to be really vital in our world.
Sure.
Yeah.
Thank you very much. Any more questions, friends? The last one. If nothing is there, I would like to thank. Any questions? Last one.
I just have one question.
Okay, sure. Last one.
Can you cite some areas wherein this AI has been really very successful?
Sure. The biggest one that I'm aware of right now is in sort of in medicine and in doing diagnoses of specifically of cancer diagnoses. There are a number of AI systems that have been built to do sort of radiology analysis. Radiology is largely driven by the analysis of images, right? You do an image of the internal workings of someone, and then you take a look to see if there are cancerous cells, if there's a problem with the cellular structure inside of a person, right? There are systems that are being built now that analyze those images to determine whether or not it's cancer or whether or not it's something else. And those systems have been extremely reliable in making that determination, often as good as a human at making those decisions. And so that allows for cancer to be found much earlier. It allows for diagnoses of things that need to be treated much more quickly. And so that's an example of where a machine learning system, I think, is doing a huge amount of good, and that's been going on for a few years now. So.
Oh, so good to hear. Thank you, Jason.
Yeah, thank you.
So thank you very much, the participants. I would like to thank you very much, actually, Dr. Jason, who has given an inspiring and informative and educative talk. And I can see all the participants enjoyed and participated in the talk. That's actually very interesting, of course. And as I mentioned, of course, as a token of appreciation, of course, normally this university will be sending a memento to all the speakers. Actually, this I'll be sending by Monday by speed post your address, of course.
Well, thank you so much.
So now actually I would like to request my colleague, Commander Rajkumar, who will be actually giving the formal vote of thanks to both the speakers.
So I must say, first of all, good afternoon and good evening and good morning. Good afternoon to Dr. Fiona Murphy. Good evening to one and all who are a part of this webinar. And good morning to Dr. Jason Griffey. So it's wonderful to present a vote of thanks, and it's a wonderful moment where we are celebrating in the globe afternoon, evening and morning at all on the same time. I'm honored and privileged to present a vote of thanks. First of all, I would like to take this opportunity to thank Dr. Fiona Murphy, the first speaker of this webinar, who had enlightened us with the concept of scholarly communications with particular emphasis on open science and open data. Although ma'am is not here, but ma'am's explanation of research workflow has been very elucidate. Once again, thanks to Dr. Fiona Murphy. Next, I would like to thank Dr. Jason. And the most important thing which I liked when he mentioned that when he wanted to create that we have done a lot of mistakes, it's really insight. And I hope a person of Dr. Jason caliber can only present those insights. So really, really very, very thankful to Dr. Jason Griffey for such an wonderful insights and knowledgeable talk. I am also honored to thank Professor Gurmeet Singh, the Honorable Vice Chancellor of this university, for his valuable guidance and support in organizing this webinar. Without his vision, it would not have been possible for us to organize such a great event. Thank you very much, sir. It is also my pleasure to thank all the statutory officers of this university, students, faculty members, officers and staff, not only for participating, but also for their valuable support throughout. Thank you all. Last but not the least, I would like to thank the Computer Center of the university and entire staff of DT for putting this event live through the online platform. At last, I thank each and every one of you for your graceful presence for this webinar, and also in advance for the series of webinars which our leading had organized. And the next one will be scheduled right away at the end of the month. Thank you very much, sir.
Thank you very much, the Commander Rajkumar, and thank you all the students who participated and faculty members, these research scholars, and our regular and distance students, all of course. It is really wonderful, and particularly thankful to actually Dr. Jason's speech is really wonderful, and it's in live, and it's more actually what do you call the interesting and actually interactive. So once again, thank you, Dr. Jason. I will be in touch with you